Okay, these are notes 1.7 in the SOX. The last one is talking about how to describe the spread. Okay, we're going to talk about three different things for spread. We're going to talk about range. We're going to talk about interquartile range, which we're going to talk about tomorrow in notes 1.8. And then we're also going to talk about standard deviation. Standard deviation is a big one we're going to use throughout. Okay, range. The definition of range, back you did in middle school in Algebra 1, is your highest number minus your lowest number, and that gives you what your range is. Okay, so if you go to an example here, okay, in this number here, our highest number is an 85. My lowest number is a 5. So 85 minus 5 gives you 80 is the range. Okay. When I ask you to compare distributions, okay, so one of the things you could say for spread is compare them. So this one has a range 72 minus 68. Machine A has a range of 4. Machine B also goes from 72 to 68, so that's also a range of 4. So you would say they have equal range. Excuse me. For interquartile range, I said we would talk about that later sometime. For standard deviation, we did that in class today. Okay, so if you just say we get some random numbers, and I'll just use some numbers here that they have in the book. So say we have 1, 3, 4, 4, 4, 5, 7, 8, and 9. Okay, so that's my data set. That's a sample that's being collected. If you think about those numbers on a number line, okay, we have 1, we have 3, 4, 4, and 4, 5, 7, 9, 8, and 9. There's my dot plot. Okay, so the first thing, standard deviation is sort of an average from the mean. So the first thing we need to do is we need to find the mean for these numbers. So x bar is my symbol for mean, okay, for a sample. So I'm going to take 1 plus 3 plus 4 plus 4 plus 4 plus 5 plus 7 plus 8 plus 9 and divide that by the 9 numbers. Gives me an answer of 5. So I know my mean is 5. Okay. So 5 right here is my mean. So how far away are they from the mean? Well, this one's 1 away from the mean. This one is 2 away from the mean. This one's 5 away from the mean. This is 2 away, 3 away, etc. Okay, so we have different distances from the mean. So one way to find that distance is if you take that x and subtract it from my mean. So 1 minus the 5 is 4 away. 3 minus the 5 is 2 away. 4 minus the 5 is negative 1 away. And that one are the same. 5 minus 5 is 0 away. That's exactly on the mean. 7 minus 5 is 2 away. 8 minus 5 is 3 away. And 9 minus 5 is 4 away from the mean. Okay. Now when I say average distance from the mean, now if you take these and add these up and divide by 9, it would give you an average of 0. Okay, because you got your positive and your negative numbers. So to remedy that, in Algebra 1, you did something called the absolute value deviation, which isn't really used very much. Okay, so we're not going to talk about that, but we're going to use standard deviation. So what we do with these numbers is we square these. So we take that, whatever was subtracted there, and we square them. So negative 4 squared is 16. 4, 1, 1, 1, 0, 4, 9, and 4 squared is 16. Okay, so you square them. After you square them, you want to add these together. That comes up to be 52. Now, what you want to do here then is, since it's from a sample, we're going to divide by n minus 1. So there are 9 numbers here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 minus 1 is 8. We're going to take 52 divided by 8. And that gives you 6.5. That 6.5 is called my variance. We'll use that later on in the year. And then to undo the square that we did, we want to take the square root of that 6.5, and that is our standard deviation. And the square root of that is approximately 2.55. And since it's a sample, we use S of x as our symbol for that standard deviation. Okay, so that's how you find standard deviation. Now, if you use Desmos, okay, which I want you to do one of these in your practice homework using this. Other than that, for the rest of the year, you can pretty much use Desmos. Well, let's talk about this. Let's interpret this as first. Okay, these numbers were how many pets people had. Okay, so the number of pets people had. We would say the number of pets people have is an average of 2.55 from the mean of 5. Okay, so that tells us how spread out data is. Okay, I'll get into that real quick. So if I have data that looks like this versus data that looks like this, this would have a lower standard deviation. This would have a higher standard deviation because it's more spread out. Okay, yeah, the numbers are farther away from the mean here than they are there. Okay, so on Desmos, you would want to make a table, and in that table, you put all your numbers. So in our problem here, 1, 3, 4, 4, etc. And then the next line, you go under Functions, and then you find the Stats menu, and then you do the standard deviation. Okay, so it pops up, STDV, and then you have to type in your X1, and then it would give you that number right there. Okay, that is how you find standard deviation. And that is 1.7.